How does an SD-WAN Edge device actually join the fabric? So you have a WAN network with your HQ, your branch offices, your cloud locations, and your data centers. And you've just opened a new branch office and you want to connect it to your existing SD-WAN infrastructure. How do you do it? Using the onboarding process provided by the orchestration function. In this video, we'll go over this important aspect of the SD-WAN, the essential steps that are taken, and how a branch router can successfully and securely join the fabric. In the previous video, we looked at what an SD-WAN deployment looks like in a real network. We saw that there are management services, control services, orchestration services, underlay transports, and WAN Edge devices at the local sites. But this raises an important question. When a new WAN Edge device is shipped to a branch, how does it become part of the SD-WAN fabric? How does it know which SD-WAN environment it belongs to? How does the device learn how to reach the management and control systems that govern the enterprise SD-WAN fabric? And how does the fabric know that this device is trusted? That is the purpose of SD-WAN onboarding. SD-WAN onboarding addresses all of these issues and ensures a smooth integration of edge devices into the fabric. We'll take a closer look at this onboarding process here. This is not intended to be a step-by-step configuration guide for a particular vendor. The goal here is to understand the logic of the process so that the implementation makes sense when you see it in a real deployment. The onboarding process is very important in SD-WAN because devices may be deployed in many remote locations. It's definitely not easy for an admin to travel to dozens of different branch offices to set these devices up. A router may be shipped directly to a branch office, it may be connected by local IT staff, and in some cases, it may be connected by someone who is not a network engineer. So the device needs a secure and reliable way to come online with minimal local configuration. This is a highly automated process, often called zero-touch provisioning or low-touch provisioning. This simply refers to the fact that the installation itself involves very little configuration steps. This assumes, of course, that the appropriate configurations have been applied to the device before it has been shipped out. So once it gets physically installed, before the device becomes part of the fabric, it must be identified, authenticated, authorized, and connected to the correct SD-WAN services. Now, at a high level, onboarding requires four things. First, the device needs basic underlay connectivity. It must be able to initially reach the orchestration or onboarding service, but it must also be able to eventually reach the SD-WAN control service as well as the other edge routers. This is done by the use of one or more WAN transport technologies locally deployed at the new branch. In other words, internet connectivity must exist using any of these technologies. Second, the device needs an identity on the network. The fabric must know which device this is. This may involve serial numbers, certificates, device IDs, or entries in an authorized device list, depending on the vendor and the method of deployment. Third, the device needs discovery. It must be able to find the SD-WAN onboarding or validation service, be discovered itself, and become trusted and processed. Fourth, after the device finds this service and is deemed trusted, it must be able to connect to the management and control services to begin receiving SD-WAN control information. Only then can it receive configurations, policies, and routing information and start actively participating in the SD-WAN fabric. Now let's walk through these processes logically and in a little more detail. A new WAN Edge device starts up at the branch. It gets basic IP connectivity to the transport side. It may receive an IP address using DHCP, a static public IP address that has been assigned beforehand, or it may have some minimal bootstrap configuration. Using the local WAN transport available to the branch, it tries to contact the pre-configured onboarding or validation service. How does it do that? It will have been configured beforehand to search for a particular public IP address that belongs to that onboarding service. This is the preparation that must be done by the ICT team before they send it out. It then contacts the onboarding or orchestration service, and this service acts as the initial meeting point for all new Edge devices. Its job is to help the new device join the SD-WAN fabric securely. The Edge device must prove its identity and discover the correct SD-WAN systems. Once the WAN Edge device reaches and communicates with this onboarding service, the device must be authenticated. Now, this can be achieved in various ways, but most vendors will include the use of certificates for authentication. It's among the most secure as well as the most automated methods. During the authentication process, the SD-WAN fabric must answer questions such as, is this a real device? Is this device part of our organization? Is it allowed to join this fabric? Which site does it belong to? Which management and control systems should it be connected to? If the device is not trusted, it should not become part of the SD-WAN overlay. This is one of the key differences between simply plugging in a router and gaining internet connectivity and securely onboarding a device into an SD-WAN fabric. Now, after the device is validated, it can establish the required connections to the SD-WAN management and control services. The management service provides configurations, templates, and operational visibility, while the control service distributes the information the device needs to participate in the fabric, such as routing, reachability, and policy information, telling the Edge device how to behave on the network. The WAN Edge then has enough information to begin operating as part of the SD-WAN environment. At this point, the device is no longer just a router with a WAN interface, it becomes a trusted member of the SD-WAN fabric. Now, let's map this to the Cisco Catalyst SD-WAN terminology and processes so we can take a look at a more real-world situation. On the WAN Edge router side, a few basic things must be in place before onboarding can succeed. First, the router needs basic transport side connectivity. In Cisco SD-WAN terms, this is normally configured using VPN 0, which is the transport VPN. This is where the WAN-facing interfaces exist, and this is how the device reaches the SD-WAN validator, the manager, and the controllers. Second, the router needs its basic SD-WAN system identity. This includes parameters such as the system IP, the site ID, organization name, and the address or host name of the Cisco SD-WAN validator. Third, the router must have the required trust information, such as certificates or the ability to obtain and install certificates so that it can prove its identity to the SD-WAN fabric. And finally, it must be authorized as a valid WAN Edge device in the SD-WAN environment, usually through the device list or provisioning process in the Cisco SD-WAN manager. Now, on the SD-WAN validator side, the important point here is that it must be reachable and properly integrated with the rest of the SD-WAN control components. The validator must know the organization name, must have a valid certificate, and must be able to authenticate incoming requests from WAN Edge devices. It must also be able to direct authenticated devices towards the correct SD-WAN manager and SD-WAN controller. So in our example here, the branch WAN Edge comes online, reaches the validator, proves its identity, discovers the manager and controllers, establishes secure control connections, receives its configuration and policies, and then becomes part of the overlay fabric. The exact commands and workflow depend, of course, upon the deployment model, software version, and whether you're using CLI templates, feature templates, plug and play, or manual bootstrap, but the logic is always the same. The Edge device needs transport reachability, identity, trust, and authorization before it can join the SD-WAN fabric. Once the WAN Edge device has been onboarded, one of the first things we want to verify is whether it has formed its expected control connections. On a Cisco Edge device, a useful command to use is the show SD-WAN control connections command. For example, you might see something like this. With this command, you are verifying that the WAN Edge device has transport reachability through VPN 0, since control plane connectivity has been established, and that it can reach the SD-WAN control components and that the secure control connections are established. Now, VPN 0 is important because this is the transport side of the SD-WAN device for Cisco SD-WAN implementations. It's the part of the router that connects to MPLS, internet, broadband, 4G, 5G, or whatever other underlay transports are being used. There's no need to understand it fully here, but we'll address it later on in the series. Now, once the control connections are up, the WAN Edge device can exchange information it needs to participate in the fabric. In Cisco SD-WAN, OMP, or Overlay Management Protocol, is what's used between the WAN Edge devices and the SD-WAN controllers to exchange routing, transport, and policy-related information. We'll cover OMP in more detail in a later video, but for now, you can think of it as one of the key protocols that allow the SD-WAN fabric to distribute reachability and policy information. You may also use other commands that are useful, such as show SD-WAN control local properties, show SD-WAN system status, and show SD-WAN OMP peers. If you're interested, take a look at some Cisco documentation about these commands. It'll show you what they're used for and what kind of outputs you will see. In any case, these help you to confirm the local SD-WAN identity, control plane status, and the OMP peer relationships in the Edge router once onboarding is complete. So let's summarize the key takeaways from this onboarding process. First, the WAN Edge device comes online and gets basic underlay connectivity. Second, it contacts the onboarding or validation or orchestration service. Third, the device provides its identity using the required authentication mechanisms. Fourth, it discovers and connects to the management and control services. And finally, it receives configuration, policy, and control plane information and becomes a trusted part of the SD-WAN fabric. The key idea is this: SD-WAN onboarding is the process that securely turns a newly connected Edge device into a trusted member of the SD-WAN fabric. In the next video, we'll look at how SD-WAN tunnels work. We'll see how WAN Edge devices use the available underlay transports to build secure overlay connectivity between sites for data plane traffic. Subscribe to the Telecom Tech channel and enable notifications so that you can follow the complete series and be informed when new videos are published. I'm Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. I hope this has been helpful for you, and I'd like to thank you for watching.